right, so what I want to do is give you guys some hints on this review, but not actually give you all the answers and such. So let's kind of first talk about the fact that, because this is the first time you're going to see all the probability mixed together. So first check and see, is this something that is normal? Is it telling you it's a normal probability curve and giving you a mean standard deviation? Or you need to do a z-score and then norm CDF to find the probability. Binomial is going to be those problems where they'll say, exactly so many successes, where you want this many successes out of, here's the key, you will have a total number of n trials. So you'll actually have, out of 152 items or out of 50 items. Independent, the probability that your one thing is not changing the fact that your one thing is not changing the probability, and we'll see that in this this review, as well as disjoint. Remember that disjoint means that the items are not overlapping. There is nothing that they have in common. Okay, so there's nobody that is doing both of those things. Is this something where you should do a tree diagram? A tree diagram are those problems where you have many conditional probabilities. If this, then that. And if this, then this is going to happen. If this, then that. And I'll come through and I'll kind of tell you which ones, so your little hints on that. And of course, drawing your Venn diagram, it might be helpful. And then of course those ones where it says the specific order in which items should occur. If it's giving you that specific order where it's laying down exactly where things should be, then that is those geometric items, like saying the first time you see something is on the 5th trial. All right, so I'm just going to go through here and give you some hints. I think that I also will go ahead and give you the answers, the number values, so that you can kind of check yourself as you go through there. Now, when I come to stamp you, you need to have work shown, though, and not just those answers in order to get your stamp. Okay, so on this one, this is a normal distribution, and so you need to treat this like a normal curve problem where you find your z-score and such. What's the proportion of observations? Finding the percentage, finding the probability, finding the proportion of observations, finding the percentage, use norm CDF. So you're going to norm CDF to find that final answer, which is going to be 1.86%. All right, on this one, these whole probabilities should total to 1, so that's how you find what's missing. And then here, to find the expected value, that's the mean, and the standard deviation of this chart. Remember, you're going to put this into list 1, this into list 2, and you're going to do one variable stats of L1, comma, L2, and that will then give you your mean and your standard deviation. Okay, so number 3, you are going to be catching exactly 5 of the next 8. Okay, so that's your hint there. I'm not going to tell you exactly how to do that, but you will end up with 22.9% chance. All right, the next one is one where you could just kind of think it out. They don't catch it, so it will not be caught until that 3rd attempt. So that's telling you they don't catch it, don't catch it, catch it. All right, to get your answer there. Okay, which will be 5.32%. All right, next. Okay, Okay, these ones we haven't seen in a while. This is from chapter 15. So I think A is pretty straightforward. Um, this one, is tourism overall. So basically, when you find this answer, you'll be getting the probability of tourism overall. Now look at how B is asked. If a student lives on Isabella Island, that means given that they live on Isabella, what's the probability that they specialize in tourism? Okay, and then C leads, it is going to fall or use the answers from part A. Because in order to test for independence, remember that you need to see if the probability of tourism, overall, is changed. Is the probability of tourism changed if it is known that you are on Isabella Island or you're from Isabella Island? Okay? And so you're going to look at these two numbers right here and compare them. Because if, given that you're from Isabella Island, has not changed the rate at which you go into tourism, then tourism and Isabella are independent. Okay? And then that's your hint. You will then need to set up an independence question for this one here with Santa Cruz, living in Santa Cruz and specializing in science. All right. E is just adding together, I think you can just do that straightforward from the chart. Because these are both randomly selected students, so those are from the entire population. All right, number 6. So with number 6, okay, we have this situation where we want to see, let's say the probability of a zoo houses one Galapagos title is 0.4, and we are studying 75 of them. So N is our number that we are studying. Okay, so of those 75, what's the probability that not more than 20, not more than 20 will have a tortoise from the Galapagos Islands? So that means you are having to find the probability that X is less than or equal to 20. So I want to see your work shown, and this is one of those sequence problems where you are using binomial CDF. Make sure you can show your work. That's 0.0112 or 1.12% is the answer you will get if you did that correctly. All right, now 7 is kind of a tricky question in that it says if 11 turtles are numbered 1 to 11, what's the probability randomly choosing a group of 5 turtles with them all having an odd number? Well, so this one we haven't seen a lot of, but to get an odd, there are 6 odd out of 11. But then in order for the next turtle to be odd, there's 5 out of the remaining 10 turtles, and then 4 out of the remaining 9, and so on. And so you can get that probability, but the reason that this is not binomial is because you can see the probability of getting an odd is changing from pick to pick because you are not replacing. So the probability is changing. That's what's making it not a binomial problem. All right. Your hint for this number 8 is that it is about, it's got several things going on. What I would do is a tree chart where you start with George, and then he's got, mating with Isabella or Fiona, or not mating at all. And then upon mating with Isabella, you have, given that he mated with Isabella, then you've got these probabilities. Given that he mated with Fiona, you've got these probabilities, and so on and so forth. And so then the final question is, what's the probability that he will have some offspring? So you want Isabella and, being successful here, Fiona and being successful here, and you want to add those together. The sum that you come up with is 15.5% chance of mating or having offspring. Okay, number 9. Number 9 is going to be one where I recommend doing a Venn diagram. And so what you're going to do is just go ahead and fill in that Venn diagram, and then I'll give you some hints on that. Okay, so you're going to do the Venn diagram on this one. You know that it is out of 120, so make sure when you make your Venn diagram, you total up to 120. This problem is, I'll give you the answers so you can check yourself. This one should be 0.4. This one's going to be 0.283 repeating. So you can check that there. And then this one is a given that, so given that the family has fishes, so out of the family that has fishes, what's the probability that they also are a family that farms? So you need to put a fraction with all the fishes family on the bottom. You're not going to do number 10. And then number 11 is another normally distributed problem, okay, where you're going to be getting your z-scores. Now, here, the thing is that you have a mean of 140. You have a standard deviation of 8. And what would be the cutoff for the top 20%? So the question is wanting to know, what the wingspan is. So what is the x value? But you don't have the ability to get a z-score from this information here. You have to use this top 20% information. So remember that in order to get a z-score, you can do x minus the mean over the standard deviation, or you can do inverse norm of the area below, inverse norm of the area below. Okay, so then if we look at the area below, the top 20%, the area below is going to be 80%. So in order to get this z-score, you need to do inverse norm of the area below. That will give you your z-score so that you can finish out the problem, which then the answer on that one, I'll just give you that so you can check and see if you got that correctly. Oh, I know. Once you get that z-score, then you solve for x. So you're going to be solving for x. I actually don't have that written down on my paper. So once you get that z-score, then you will fill into this formula here and solve for the unknown wingspan value. Okay, that's it. So I hope that helped you to get all of those questions completed this weekend.